Have you ever wondered what makes your electric toothbrush vibrate or your car move? This simple question triggers a chain of thoughts about the numerous devices we use daily. Take a moment and imagine your typical day. It may start with alarm clock's persistent buzz, followed by the comforting hum of your coffee machine preparing your morning. As you brush your teeth, barely awake, your electric toothbrush does the job for you, vibrating vigorously. On your way to work, you step into your car and with a twist of the key, the engine roars to life. You might not stop to consider the refrigerator keeping your leftovers fresh, the microwave waiting to heat up your dinner, or the washing machine that ensures your clothes remain clean. We are surrounded by machines, big and small, each humming, whirring, spinning, vibrating, and making our lives easier. These are not mere conveniences, but integral parts of our lives, away tirelessly, often unappreciated. We take their functioning for granted, rarely contemplating the ingenious mechanics behind their operations. Yet, behind every movement, every vibration, every hum is a secret, a marvel of engineering that is smaller than you might think, yet powerful enough to drive our modern world. Well, the answer lies in the heart of an electric motor. Electric motors, the silent heroes, power an array of devices we utilize daily. These motors, the unsung champions of our everyday, run the gadgets that make our lives easier. From the refrigerator that stores our food to the electric vehicle that transports us, these silent workhorses are vital to our modern living. They're not just in our homes, but also our workplaces and our educational institutions. They run our laundry machines, cleaning devices, and our digital tools. Surprisingly, they're even in our toothbrushes. An electric motor, in essence, is a mechanism that turns electrical energy into mechanical energy. It's the magic that transforms the electricity from your outlet into the kinetic movement that drives all those devices we talked about. But what's this magic? It's a simple yet profound concept. Electromagnetism. In the 1820s, a scientist named Michael Faraday discovered that electricity could generate a magnetic field. This ushered in the discovery of electromagnetism. Let's visualize it. Picture a copper wire transmitting current. As the current moves, it spawns an invisible circular magnetic field around it, akin to unseen loops you'd witness around a circular object influenced by wind. This forms the core of electromagnetism. Now, envisage coiling this wire. The magnetic fields from each amalgamate, resulting in a more potent magnetic field. This forms the basis for an electromagnet. Thus, by manipulating the current flow, we can govern this magnetic field. Faraday's discovery, besides transforming science, also bore extensive practical benefits. This discovery laid the foundation for the modern electric motor. Before we move forward, let's take a brief pause. It's time to reflect and acknowledge how far we've come in our exploration into the fascinating world of electric motors. If you've been finding our content enlightening and your curiosity piqued, do remember to hit that like button. It's a simple gesture, but it goes a long way in showing your appreciation for our efforts. It's your support that fuels us to delve deeper, research more, and create these educational videos filled with insights and knowledge. But the journey doesn't stop here. If you already, consider subscribing to our channel. It's a commitment to continual learning, a promise to feed your curiosity. And it comes with some excellent benefits. One of the key is how you'll be promptly notified whenever we upload a new video. You won't miss out on any new revelations or exciting discoveries, but the perks don't end there. By subscribing, not just becoming a passive viewer, you're joining a vibrant community of like-minded individuals, all hungry for knowledge and understanding. This community fosters a spirit of shared learning and mutual curiosity, making it a hub of insightful discussions and diverse perspectives. You become a part of this enriching network of curious minds just like yours, eager to delve into the minutiae of complex concepts and unravel the universe. So seize this opportunity. Don't miss out, because each click, each subscription, each like adds momentum to our shared journey of discovery. Now let's unravel the mystery behind the basic parts that make up an electric motor. An electric motor has few basic parts: a power source, a stator, a rotor, and let's explore briefly. The power source provides the electrical energy. It could be a battery or an electrical outlet, for example. It's the essential push behind the motor, providing the crucial energy. Next, the stator, a stationary part that produces a magnetic field. It's the backbone of the motor. Then we have the rotor. This part rotates under the influence of the stator's magnetic field. It's the active element imparting motion to the motor's output. Lastly, there's the commutator. It switches the current direction in the rotor, ensuring it spins continuously in the same direction by reversing the current for each half turn. It's the hidden director, controlling the entire operation. These components work together to convert electrical energy into mechanical motion. The beauty of an electric motor lies in this delicate interplay of parts, each contributing to the incredible transformation of energy. Each playing its role, they form a harmonious ensemble that transforms electrical energy into mechanical motion. The beauty of an electric motor lies in this intricate dance of parts, each doing its bit to create the symphony of movement. Now that we know the parts, let's delve into the working principle of an electric motor. Within an electric motor, electromagnetism is key. As electric current travels through a wire, a magnetic field is produced. This field is crucial to the motor's function. A motor has a rotor and a stator. The stator stays put and sustains a constant magnetic field. The rotor, however, is an electromagnet. With electric current, the rotor develops its own magnetic field. This interaction between rotor and stator magnetic fields causes the rotor to rotate, driven by the repulsion and attraction of magnetic poles. However, if the rotor aligns with the stator, wouldn't it stop? This is where the commutator steps in, reversing current direction every half turn, enabling the rotor's continuous rotation. The mechanism we've explained is a basic DC motor's function. However, motors in reality are often more intricate, featuring multiple magnetic pole pairs on the rotor and stator, improving performance. Despite the complexity, the fundamental concept remains identical, utilizing magnetic forces to generate motion. And that, in essence, is how an electric motor works. So, let's quickly recap what we've learned. Our journey began with a simple question: how does an electric motor work? This led us to explore the fascinating world of electromagnetism and mechanical energy, discovering that the principle of electromagnetism lies at the heart of every electric motor. We delved into parts of an electric motor like the armature, the spinning part that does the work, and the commutator, responsible for switching current direction. We also looked at the field magnet that produces the magnetic field for the armature to operate. We then moved on to the working principle. An electric current through the armature creates a magnetic field which interacts with the field magnet's magnetic field, causing the armature to rotate. This rotation powers devices like fans, drills, and even some vehicles. The direction of rotation can be reversed by changing current polarity, and the speed controlled by varying the current amount. These unique features make electric motors versatile and widely used. Never overlook this silent hero that powers our daily lives. Next time when you switch on your fan or drive your car, remember the silent hero, the electric motor that makes it all possible. Thank you so much for joining us on this journey through the world of electric motors. It's been a pleasure sharing these insights and discoveries with you. We find it truly exciting to delve into such captivating subjects, fueled by your inquisitive nature. Our world is a treasure trove of uncharted territories and novel concepts, awaiting your exploration. Lifelong learning is a remarkable journey, and we're glad to embark on it with you. As we come to the end of this video, we encourage you to continue your quest for knowledge. Share this video with friends and family and contribute to their learning experience as well. The like button is there for you if you find our content worthy. Make sure to subscribe to our channel and tap the bell icon to stay updated. We have an assortment of intriguing topics lined up for you. Our upcoming video will delve into a groundbreaking technology that's reshaping our. Keep the spirit of curiosity alive and stay tuned for more educational content. Don't forget, every day brings new learning opportunities. See you in the next video.